Right, we know about forces and we know about electric fields and we know about charges, but how do they all link together? There's something called electric field strength, which is how much force there is per unit charge. So the electric field strength is the force per unit positive charge. The force and the electric field both have associated directions, and therefore they are both vector quantities. The direction of the electric field is always the direction in which a positive point charge would move, so it is always from positive to negative, because it would be attracted to negative. So we've got force in newtons and charge in coulombs, and therefore electric field strength is measured in a unit called newtons per coulomb. Newtons per coulomb. Again, there's another thing that you can say with electric field strength. You can say, but I happen to know that the force is actually equal to K Q1 Q2 over R squared. So what if I put that in for the force and then divided that by the charge of one of the charges, like Q2, and then I would find that my electric field strength is actually just KQ over R squared. The Coulomb's constant is exactly the same, and we can either measure the electric field strength in volts per meter, which we kind of do when we do electricity, don't worry, or newtons per coulomb. They come out to be the same thing. Charge is responsible for the field. That's the charge that you're looking, the actual point charge that you're looking at. Normally in these problems you'll only be given one charge, as opposed to when you're asked to find the force between two charges. You need to look at the words very carefully. Are you being asked for the electric field strength? Are you being asked for the charge? And then of course distance needs to be in meters. So find the intensity of an electric field, 50 millimeters, don't forget, 0.05 meters. That is from a certain point charge. It's microcoulomb, so it's times 10 to the negative 6. So I'm going to say electric field strength is equal to KQ over R squared, and I land up with 9 times 10 to the power of 9, 50 times 10 to the negative 6, and distance is 0.05. Don't forget to square it. I land up with 1,8 times 10 to the power of 8 newtons per coulomb, but ideally I should have a direction as well. And this negative sign over here tells me that this particular thing would move in the direction from positive to negative. So this would be a electric field intensity that would be attractive. This negative thing would be, it would attract positive charges towards it. If two charges are causing different electric field strengths at a certain point, an electric field is a vector, and therefore you could be asked at that certain point to work out the resultant electric field. And we'll practice a little bit more of that going forwards, and you can use vectors to calculate the resultant. So you would have one electric field going to the left, let's say 3 newtons per coulomb, and then you have another one going to the right, 5 newtons per coulomb. What is the resultant electric field at that point? And you would subtract the two from one another.